Hello guys, I'm here to teach you about 3D printing models that you've made in any CAD software. First off, when you make a model in any CAD software, when you're done, you want to export it as an STL file. An STL file is one of the most common files used when 3D printing. Once you do that, you want to download a slicer software. I'm using Ultimaker Cura. It's a free software and it works well, and it accepts STL files and exports as G-code files. Make sure that G-code files are compatible with your 3D printer. Now, what a slicer program does is it converts a model into data such as paths, density, thickness of layers, all that stuff, so the 3D printer knows where to print, how fast, how hot does it need to be, how dense the model is, how it's oriented, where to support the model. So, to start off, I have Ultimaker Cura pulled up here, and I'm going to import my STL file, and this is the file I'm using. It's a webcam mount I have. It's a simple model I made in Blender. That's not CAD software, it's more animation. I recommend using Fusion 360 if you were to learn CAD, but this is something I made quickly to clip on my webcam onto my monitor. And once you export it in, it will be scaled to a certain size. Sometimes it may not be the size that you modeled it to be, so you just want to go in here and make sure it is. Check out the size. That's what I have it modeled to be. And if you change one scale, what can happen is it will change all other axes because it's uniform scaling. So make sure that you try to get as accurate as you can. This is good. And snap scaling means it's going to snap to certain increments, such as every 10%. And then here you have transformations such as obviously moving along any axes. Although I don't recommend moving around along the z-axis because you want it stuck to the plate, so it won't do that because it's just making extra supports that take too much time. And usually the scale you want depends on what you're modeling. Location doesn't always matter, it can sometimes, but one of the things that does matter is the rotation, because what can happen is when you're modeling something and you're 3D printing it, this could be hot filaments, so the filament's going to be soft, so it might sag in areas where there's a lot of plastic hanging, so it has to build supports. So you want to rotate it and have it print on a orientation that doesn't cause that much support, that doesn't need supports, so that way you can print faster. So for me, it's better to print like this, where it's just a little bit of support right here instead of a lot of support inside, and so that way it'll print faster. Here you have other options such as mirroring, so if I want to rotate it and I don't like the way it's oriented, or I need to make two mirrored ones, for example, if you're building a robot and you need a part for the left side and the right side, you can make one part and then duplicate it and mirror it, so that way it's working for both sides, and so that way you don't have to model two separate CAD STL files. And so here there are different options. Print as support basically means obviously it's going to be a support for something else. Modify settings for overlap, that's if you have two models intersecting each other. And don't support overlaps, which is, if they do overlap each other, then don't, make sure they don't print. And here you have support blocker, which block supports. And another thing is, some of these settings are specific to Ultimaker's 3D printers. This software does work for most 3D printers, but Ultimaker makes their own, and so they optimize it for their 3D printer. So I have a Creality Ender 3 Pro, which I'm using. You can add any printer you want, and I'm using PLA plastic, which I'll go into later. And so once you have these settings, that's good. Then you can go into the more specific settings about how it's going to 3D print. So you have quality. Quality is obviously how good it looks and how good it prints. Generally lower is better, but it's faster if you're doing higher quality print. No, I'm not going for any aesthetic look or anything holding any weight or needing structural support, so I can go for a relatively low quality print and I'll be fine. This is just meant to hold a small webcam. Now, for shell, you have obviously the thickness of the walls, and so generally you can leave this as the default unless you need something done really fast. Then you can lower it. I don't recommend it because it's really weak. If you need something that's really strong, raise it up so that way the walls are more dense. And then here you have infill density. Infill is basically, it's not just going to print solid plastic because that's going to take a lot of time. You can if you have to, but it takes a lot of time. So what it's going to do instead is it's going to do some sort of pattern inside. Right now I have cubic, which I'll show you how it looks later. Now material, this is mainly for temperature. So the build plate, which is the surface the plastic's going to be on, 60 degrees Celsius. The nozzle is going to be 200 degrees. That's good for me, and it works for my printer. And speed, obviously how fast the nozzle is going to move as it's printing everything out. I don't recommend changing it. It's usually good unless you run into problems with the plastic you're using or the model just isn't working. Might be better to slow it down. Travel, this is more oriented towards Ultimaker printers, which it's not really important. It can help in some situations, but it doesn't really matter. Cooling, it's about the fans. I just enable print cooling and have the fan on, because make sure that the nozzle and the build plate are being properly cooled and so they don't overheat. And now supports. Supports, I recommend having supports on because they'll be better quality prints. And support placement, it'll depend. You can do everywhere or touching the build plate, because let's say here, it's going to need supports right here. So instead of having it be printing like on top of the plastic layer right here, you can set it up in experimental modes where it's going to have it print on the build plate and the support's going to extend out underneath it. However, that can take a lot of time. It is experimental, so it's not really as stable. I recommend doing everywhere for most prints. However, if you're doing something that's a little generally weaker print, such as if you're just doing like a model or something of something you put on your desk, then it can depend. And so you'll have to look at what you're modeling and how you want it to look. And support overhang angle is how steep of an angle does it have to be before it starts making supports. For example, here it's a 90-degree angle. If it was a 45-degree angle, so if it was going or less than 45-degree angle where it's going up, it might not need supports because it can just print directly on top of the layer below it, just a little bit skewed. But most of the time 45 degrees works. Now, build plate adhesion. Build plate adhesion is basically saying how do you want the plastic to stick to the plate before you actually print the model. There's three main kinds. There's skirt. Skirt just means it basically takes the model and around a few centimeters or inch around the model, it prints out a layer of plastic. That's just so it gets the plastic moving, so there's not any feeding problems at the beginning of the print. Brim. Brim is where you have one solid layer of plastic below the model, so it prints out the layer, then it'll print the model on top of it. And raft. Raft is a thick layer of plastic printed, and then they print the model on top of it. I recommend using brim or raft. Skirt can work really well if you have good temperature settings, which I'll go into later. But I'll be using brim right now because this is a small print and it doesn't really matter. But if you need a lot of accuracy and you don't want to worry about warping, raft might help. And again, here you have dual extrusion. My printer doesn't support dual extrusion. If yours does, there may be other settings for it. I'm okay with the settings that are here so far, so I'll go ahead and slice my model. There you go. It's going to take an hour and 11 minutes, so let's preview the model. And you see here, this is what the model is going to look like. And you can see the supports here. So what I can do is I'll go into helpers, get rid of all the helpers. That means rafts, supports, brim, skirts. Those are all helpers. This is the model itself, and you can see how the plastic is going to print. So what you can do is you can go down a little, and you can see the layers below it. And so as it's going to print, you can also see how the nozzle is going to move. Now, when you're 3D printing, these are we have to focus on: the infill and the wall supports. The infill right here, this is cubic, which is the pattern. It's a three-dimensional pattern, meaning instead of just being a pattern like a honeycomb or prints a honeycomb and puts the layer on top of each other, it moves in three-dimensional space, which adds a little bit more structural integrity. So I also said at 20% because this isn't that structurally strong. It doesn't need to be. And so I can have it a little bit lower, but if you're doing a part for robotics or a part for any mechanical operations, it's better to have a relatively high infill density to make sure it's stronger. So you can just go through, check if there's any issues, and there don't seem to be. And if anything's grayed out like you see here, that means that it's not going to print because there might be issues with the file itself or the model. And so you're going to make sure that there aren't any issues. And most of the time what issues are is if you have stuff like non-manifold edges, where you have edges that don't create a face, where it's just like a circle without any thickness, for example, it can't print that. So also you have intersecting faces or vertices where faces intersect each other, and it can't just print one face and then the other face. You have to make it so that faces aren't intersecting, or edges or any sort of geometry isn't intersecting one another. Now we'll go into the infill right here, or not the infill, the supports. So here's the support, and the way it's printed, it prints out a small weak layer underneath and then prints out a thinner block of plastic and then another small layer on top. So this way you can easily snap it off your model and make sure that you don't have to worry about any support sticking to the model, or you don't have to worry about part of the model coming off as it's really weak. There are other types of supports out there. The way Cura does it is it builds blocks directly underneath any sort of hanging edge, while others, Cura or not other slicer programs might instead do like spaghetti infill, where they just fill it in, or they might have just pillars basically going up and supporting the edges. But the way Cura does it is good, and it works for most models. So here you can see the infill and where it is, and so in really thin areas there's not going to be a lot, but there's also space for the walls, so you can see. And that's how you slice up a model that you have. And now what you want to do is you can save it. However, I'm going to export it onto a USB drive, which can connect to an SD card. And my printer uses an SD card for the G code that it stores. So I put it on an SD card, so when you put it on, it'll just say right here, save to removable disk. You can do that. And so I'll go ahead and save it, and I'll show you what to do when you get to your printer itself. So this is my printer. It's an Ender 3 Pro made by Creality, and I have it set up to run the 3D print that we made, the G code that we just exported, and I put it onto an SD drive that's right here. I have the print running. You can in this, while you can't see it on camera, it shows the data, the temperature, the speed, how much time is left, what's happening right now. So right now the bed is heating up. The bed will heat up to around 60 degrees Celsius, the nozzle 200 degrees Celsius, so it's twice the boiling point of water. And so what it will do, this 3D printer and most FDM 3D printers they take filament and deposit the filament onto a print bed. So it runs it through towards the nozzle, which is heated. As the filament melts, it will be pushed through the nozzle, and then it will be laid down onto the bed, and then every layer below it. Now, one option you can use when 3D printing is on your bed, you can put some sort of adhesive on to help the print stick. Some people use hairspray. I use glue, just a regular glue stick, because it comes off really easily, doesn't stain it really much, and very easy to use. Just take a glue stick and just rub it along. That's good. And then every once in a while, if you are using adhesive, you want to take your print bed and clean it off. Because I'm using glass, it's easy to clean off. It just takes rubbing alcohol, a little bit of wiping, and it's good. And another thing you can do is make sure that when you're 3D printing, your bed is level. Some 3D printers auto level their beds. This one doesn't. So what you do is that there's small wheels under here that you scroll on each 4 corners. What you can do is put your nozzle up right below each corner, right above each corner. Take some sort of paper like an index card, or you can use a dollar bill. You do this while it's turned off. Put it right up against the printer. Go as low as you can with the nozzle, and then just adjust it so the nozzle is barely above the printer and the dollar bill or the index card barely goes through. Do that for each corner in the middle. Another option, which tends to be better, is you can go to sites such as Thingiverse and download test 3D prints, which go ahead and do a print all across the build plate. You can test how level it is by looking at the result of the print, and you can do it really quickly. The prints aren't that long, so you can go ahead and set it up. If there's any problems, fix it, and then you can go ahead and do another print and test it out. Now, there's 2 main types of materials you can use in 3D printing. I'm using PLA plastic, but there's also another one called ABS plastic. Now, they both have their pros and cons. Pros of PLA: very easy to use, very easy to work with, doesn't need a lot of specific settings, and it's fairly cheap. The cons, though, is it's very brittle. It's not very structurally sound. I wouldn't recommend using this for parts for robotics or mechanics. And so it's not really a good option for robotics, but for my use it's perfect because I'm just doing a simple print. ABS pros: obviously it's more structurally sound. It's better for mechanical parts as it holds up better under stress. Cons, though, very hard to work with. A lot of finicking around, specific temperatures and settings and speeds, and so you'll have to play around with it, and it's really hard to work with. But once you do get the settings, it does work pretty well, and it does print very well. But a lot of times it can change, and you'll have to change the settings over time and make sure that you get your settings right for a perfect print. Another thing about printing is that you want to make sure that your environment that you're printing in is relatively evenly heated, because what can happen is, because the build plate is pretty hot, what happens is that when it's hot, obviously things expand. When it's cold, things contract. But if the bottom layer is hot and the top layer is cold, the top layer contracts and it pulls the bottom layer off the print bed. And so it can cause issues while printing. So this is what happened in one of my older prints. As you can see here, it started to contract on this side and it pulled the print off the bed. This side's flat, but you can see how it started to warp over here and curl towards this one edge. There are different ways you can help this. When you're modeling the STL file, go ahead and add a little bevel to the edges, so it's not just a sharp edge, as that tends to help. But other than that, using an FDM 3D printer is pretty easy. Once you get the settings right, you can learn to play with it however you want, get the results you want out of it, and it'll work just fine. I love my 3D printer, and it works pretty well for me. And another good thing about most printers is that you can edit the settings while you're in print. So what I can do is I can go, for this 3D printer, I can go to tune, go down to stuff like speed, temperature, fan speed. What I can do is, let's just say the print's a little bit too high off the bed. Well, I can go to baby step Z, and slightly adjust it by millimeters, the increments in millimeters. So this is around 1/100th of a millimeter, and so I can go around 1/100th of a millimeter up and down. However, my 3D print looks to be working pretty well, so I'll leave it at 0. And there's other things you can do. If you have to change the filament because it's running out, you can go and click that. However, it does stop your print. Flow is how much plastic's coming out, not necessarily the speed. Speed you can do here. Speed is how fast the nozzle itself is moving, how this is moving, not exactly how fast the filament is feeding. And so you can go back, and there's other settings you can do, such as you can pause and stop the print. For example, if you have to fix the printer or something, then you can do that. And here you have temperature, motion, filament, store the settings. So for example, if you edit default settings, then you can store them, and so you can control that. But most of the time you don't have to worry about it. It's fine. There's little adjustments you have to make, and once you're done, you can get the print ready, and I'll be back when it's done and show you how it looks. So here is my 3D print finished, and now all you have to do is take it off. You see here, this is the brim that I was talking about. The print bed wasn't as level as I wanted to this part to print, but it's still good. Now all I have to do is just peel this off, and you see the support under here. Take something small like a screwdriver or something, just pop that out, it'll be fine.